An international team of astronomers has created the most detailed and largest ever map of dark matter, a mysterious substance that permeates the cosmos. From microscopic particles to distant stars, what the human eye can see, or visible matter, is only 5% of the universe. The rest is invisible, so-called dark matter and dark energy, which do not absorb or emit light. Using a telescope in Chile that can detect dark matter by its gravitational pull on starlight, astronomers have mapped the spread of dark matter across 100 million galaxies. The map shows dark matter is less clumped together than previously thought, throwing doubt on Einstein's theory of general relativity.
So you might think that that's a bad thing, that maybe, oh no, physics is broken. But for physicists, it's extremely exciting because it means that we can find out something new about the way the universe really is.
Whether these results rewrite our understanding of the cosmos or simply mean the theory needs a few tweaks is still to be determined. Professor Alan Duffy from Swinburne University says mapping the substance has been a huge effort.
Dark matter is an invisible component of our universe. It has mass, it has gravity, but we think it's an entirely new form of matter that is effectively entirely invisible, which, as you can imagine, does make it a little hard to try to figure out where it is and how much of it is. But the last 40 years of astrophysical efforts have honed in on something that outweighs everything we can see about 5 times over. And then, of course, we have this latest effort by the Dark Energy Survey to map it out. The dark matter is essentially the backbone around which galaxies grow. Its gravity is the reason the Milky Way exists. So that means that anytime you see galaxies, you know that there must be some dark matter around it. In other words, you use the galaxies, in this case, 226 million of them that the Dark Energy Survey mapped over the last 6 years, to act as essentially morning dew on the spider web in your backyard, revealing, tracing out with the galaxies the underlying dark matter. They went a step further and used the images themselves of those galaxies that were essentially distorted, or the shapes of the galaxies were slightly twisted as they traveled through the dark matter on their way to us, using Einstein's theory of general relativity and an effect called weak lensing to just ever so slightly distort the images, but again, revealing the presence through its gravity of the otherwise invisible dark matter. Some exquisite work that has now created one of the most accurate and certainly the largest maps of dark matter in history. It isn't quite as clumpy as we would think. So essentially, big clumps of matter fall together and make bigger clumps of matter, and that is essentially how galaxies are growing. Big things have extra gravity, they pull in extra stuff. So the big things get bigger and the empty regions get emptier, and these are called the voids. And what the map is revealing is the universe isn't quite as extreme and split into these clumps and voids as what the supercomputer simulations, the kinds that in fact I run, would suggest. It means that there might be either something slightly different in the beginning of the universe at the Big Bang and setting how the clumps begin to form together, or maybe Einstein's theory isn't quite right on the biggest of scales, these scales at which these clumps and the voids are forming. So either there's something a little wrong at the start in the Big Bang versus what we think today, or Einstein's theory is either way. We're pretty excited, but that being said, I just think the map itself is an exquisite effort to create a map of the invisible.